This is the Artillery Sidewinder X2, and in a previous video I took a look at the Artillery Genius Pro, and I really like that printer. And as far as I can tell, this thing is just a bigger version of the Genius Pro. So when Artillery reached out and asked me if I wanted to try the Sidewinder X2, I didn't hesitate and I agreed. I received this printer about 3 months ago and I've been using it non-stop since, and that's of course because I want to give you guys the most accurate and honest information possible about this machine. So let's get started and see if the Artillery Sidewinder X2 lives up to its military grade name. First, we'll start with the unboxing of the Sidewinder X2, and it comes adequately packaged with lots of foam, and fittingly it comes packaged in multiple layers. The very bottom layer is the base of the printer, which houses all of the electronics, and it has the glass build plate on top. So we're going to carefully flip this thing over, because as part of the unboxing process, we're going to be taking a look at the electronics inside.
Any ideas?
I like to do this with all of my printers upon first receiving them, especially if I eventually plan on leaving them running unattended. Despite voiding the factory warranty, this gives me peace of mind knowing that none of the connections have come loose upon transportation from the factory, and it gives me an overall sense of the build quality of the printer. You can gain a lot of insight looking at attention to details in areas that they don't normally expect you to see. Under the hood, everything looks pretty tidy on this printer. I see pretty good wire management, especially coming off of this AC heated bed. That's going to be super important. And then looking up towards the screen, there's not a whole lot to see here. A few cables, things are tied down, which is good. There's not a lot of loose wires. On the main board, I see that they used ferrules in the screw connections and not just tin tips on exposed wire, so that's also very good. Around the power supply, they have all the wires bundled together with one zip tie, which I'm not a fan of, and I'll probably replace with something softer. Moving on to the assembly, I put the cover back on the bottom of the base of the printer, and I've taken the entire gantry assembly out of the box, and we're going to be putting this on top of the base. And just like the smaller Genius Pro printer, it looks like they've used the same assembly strategy here, where there's one connector at the bottom of one of the pillars, and this is going to connect the ribbon cable that goes up to the print head. Line up the male and female connectors and push the frame down as straight as possible. Do not insert those connectors in on a bad angle. I've tipped the printer on its side and I manually moved the gantry up, and you can see how the top of the printer is overhanging the table. So the frame is not on an angle, it's sitting nice and square on the table while I put these larger M5 screws in place. With all 4 screws tightened down, we can flip the printer back upright, and we can take a look at the back of the printer where you'll find the connectors for the Z-axis motors. From the factory, they're taped down onto the base and they'll line up with the Z-axis motors. Those connectors are keyed, so you cannot screw them up and insert them backwards. And then looking at the printer from the back on the right hand side, there's also this one extra plug, which I believe is for the filament runout detection sensor. On the left, there's a spare connector, which we will not be using, and on the bottom, there is the voltage selector for the AC incoming voltage. Make sure it is set appropriately for your country's voltage. While I was plugging in the Z motor, I did notice that mine was a little loose, and it's always a good idea to do a once over on your printer and make sure all the fasteners are tight. Sometimes they miss things at the factory, or sometimes things rattle loose during transportation. Catching these things early on will prevent you from having to troubleshoot weird print artifacts later on, especially if you're a beginner. And the other big important thing to check here is the tightness of your print bed. On the Sidewinder X2, it runs on V-wheels, and the adjustable V-wheels are on the right hand side, and you can use the included wrench to reach underneath and make adjustments to the eccentric nuts on those V-wheels. Make small adjustments to make sure all of the V-wheels are in contact with the extrusion member that they're riding on. The motion of the print bed should be smooth with no play in it. If they're too tight, it will almost feel like there are flat spots on the wheels. Moving up to the top of the printer, we can now take a look at assembling the spool holder as well as the filament runout detection sensor. In the box, you get these 2 pieces here, and what's missing are the rollers that connect them, and they can be found inside of this nice little bag of spare parts. Artillery gives you a pretty nice little spare parts kit, including a spare limit switch, a USB drive, some extra V-wheels, a spare volcano nozzle, tools, USB cable, and of course the filament rollers, and a ribbon cable as well if yours ever gets damaged. And now we can take those rollers and you can kind of see how this fits together on the table. So the rollers have holes in the end and they just slip over top of the nuts on the 2 metal brackets. And it's just going to kind of sit like this, and it doesn't seem all that stable, at least while it's sitting on the table. But once we get it up here on the printer, it'll make more sense, and you'll see that it does work actually pretty well. The bracket with the runout detection sensor on it slips into the blue frame, and you'll see these notches in the frame, and the other half of the spool holder fits into the larger of the two notches. And you can see here that a portion of it extends down past the little cutout, and this is where we install our thumb screw to lock it in place. But before we tighten that all the way down, we can use the wiggle room that we have to fit those rollers in between those bolts. We can kind of squeeze the two halves together and then tighten the thumb screw down completely. If you did it correctly, the rollers should spin freely, and this is where the spool will sit on top of eventually. Then we can grab the remaining loose wire and connector, and you'll find these little features on the back of the frame that the wire will just snap right into, and we can route that wire down and through the spool holder and plug it into the filament runout detection sensor. Back at the front of the machine, we should also check the tightness of the V-wheels on the X carriage, and in this case they do feel tight, a little too tight. At the bottom of the X carriage, there is a single eccentric nut that you can use to adjust this tightness. And just like with the print bed, you're looking for a very smooth motion with no play and no feeling of flat spots. Before we can get printing, we need to set a few more things up. And the first thing we need to do is remove the paper cover over the glass print bed. We can turn our machine on and we can preheat the print bed. So to do that, we're going to hop into Tools. We're going to press the Heat button, and you can see right now in the bottom left hand corner it's set to the extruder, so we're going to press that and it's going to switch it over to the bed. It's going up in increments of 10 degrees, and we're going to set it to 60 degrees Celsius. And then we can also move over to the extruder and preheat that to 180 degrees Celsius. Now this is done in preparation of setting the Z offset of the nozzle, and preheating the nozzle, in my opinion, isn't really that big of a deal. Definitely heat soaking the print bed is. Next we can hop into the manual leveling menu and hit 5th, and this is going to center the print head and set it to what it thinks is Z equals 0. And you can see I have a piece of paper and I'm trying to slip it between the print bed and the nozzle, and it just won't fit. Back in the menu we can hit the More button, and we could have also pressed Z equals 0, and that probably should have done the same thing where it sets the print head to Z equals 0. But regardless, I'm going to press the up arrow, and this is going to move the nozzle up 0.25 millimeters at a time. I'm going to continue to do this until I find a height at which the nozzle is squeezing the piece of paper against the glass print bed just slightly. Then we're going to go back to the manual leveling menu. I'm going to press first, and this is going to bring the print head to the bottom left hand corner of the print bed. And again, that piece of paper will not fit between the nozzle and the print bed. So I've pressed the first button again, it raises the print head up and lowers it so I can fit the piece of paper in there. And then we're going to make some adjustments to the bed leveling knobs at that corner of the printer. Turning the knob clockwise draws the print bed down away from the nozzle, and counterclockwise raises the print bed up. And we are going to repeat this process for all four corners of the printer. And what we're shooting for here is that light drag between the nozzle and the print bed on that piece of paper. You're going to want to go around the print bed more than once, because making adjustments at one corner will have an effect on the other corners. Try not to make really big adjustments all at once at one corner. It's better to continue to go around even 4 or 5 times if you have to, making small adjustments at a time until you're happy with all 4 corners. Then you can hop back into the auto bed leveling menu and hit the auto bed leveling button, and the machine will take over and probe the print bed. When it's done, it'll park itself in the back right hand corner, and you're going to smash that EEPROM save button. The machine doesn't seem to give you any indication that it's saved, so I like to hit that button several times just to be sure. And then when I hit that Z equals 0 button, it's going to move the print head back to the middle, and I'm going to double check with my piece of paper. Then you can go back into the heating menu and preheat the nozzle to roughly 210 degrees Celsius for PLA. Load in a spool of filament at the top, guide the filament through the filament runout detection sensor down to the print head, push the lever on the print head to release the tension on the extruder, and then you can manually purge some filament, and now you've primed the nozzle. Slicing files is outside of the scope of this video, but I will tell you that I use Prusa Slicer, and definitely keep watching because I do have a tip for you guys later on if you would like to use Prusa Slicer with this printer. So for now, we'll just get into the very first print, and I'm printing the classic Benchy. Now, despite all of the efforts that we went to earlier setting the Z offset, it does still seem like we're a little far away from the print bed. And from my experience with any brand of printer, this seems to be pretty normal. The first time you print, you're probably going to have to go into the options menu, and we can do a live adjust on that Z offset. In my case, I pushed the down arrow 1 or 2 times to get that nozzle slightly closer to the print bed and get a little more squish on my first layer. And if you're new to 3D printing, it's just going to take a little bit of experience to be able to identify what's too squished, but it is pretty obvious when the nozzle is too far away because of course nothing will be sticking to the print bed. In this case, I was able to perform that live adjustment of the Z offset fast enough that the print still went off without a hitch, and throughout the entire print I could tell that my settings were pretty dialed in from the start, and this is because I also own that Artillery Genius, which is basically the smaller version of this printer. However, for this part, I did use some old off-brand PLA that I had sitting around that I really just wanted to get rid of. And truthfully, it's kind of bad practice because whenever you're dialing in a new machine, you should be using a material that you're familiar with. And so on this part, you'll see some stringing that I'm very confident that I can get rid of in the next prints when I switch over to some better quality material. Overall, the rest of the print looks really nice. The walls are very smooth, the layers are very consistent, and all of these small details are present. To me, this indicates that the mechanical assembly of the printer went well, and now I can focus more on the slicer settings in order to get even better quality prints. And that's just what I did. I moved over to some better quality filament. In this case, I'm using white HT from Filaments Depot, and I'm slowly starting to dial in faster and faster settings until I run into quality issues. I always like to start with pre-configured print profiles within my slicer, so in this case Prusa Slicer does have settings for the Artillery Sidewinder X2, and as I said, I take those initial settings and I start to bump up some values like the perimeter speeds and infill speeds and that sort of thing until I run into quality issues. And in this case, everything still looks good. I made some minor changes to the slicer profile, but overall I can tell on this bigger part that the auto bed leveling is working. You can see the first layer went down smooth. There's no stringing between all of those hexagons, and the part did not warp. I had no first layer adhesion issues across that print bed. One setting I don't play with a whole lot is the first layer speed, and that's because I will happily sacrifice some print speed for reliability. And it's not until you get to these second and third solid layers that I'll really jack the speed up, because once the first layer goes down, that's the foundation for your print. If it sticks well to the print bed, then the rest of the print should normally go off without any problems. And despite the increased speed, this part still looks very nice. That volcano nozzle on the Sidewinder X2 can keep up no problem. There's a small amount of pillowing on the top solid layer, but I would attribute that more to the fact that I'm printing this HTPLA at 230 degrees Celsius. This is a functional part that I'm printing, and I'm going to prioritize the strength over the way it looks, and if I really wanted to get rid of that pillowing, I could just add a fourth solid layer on the top layer. Overall, I'm happy with the print, and as I had mentioned, these parts are functional, so I can confirm that they did fit within the assembly, so it would seem that the dimensional accuracy of the printer is good. And for these larger prints, I eventually settled in at 0.3mm layer height at 120mm per second perimeters. Beyond that, I didn't really see a whole lot of reduction in print time by increasing the linear speed, and that is of course because the acceleration values of the printer are what's going to be the limiting factor in the end. Also, with the standard 0.4mm nozzle, the 0.3mm layer height is at the upper end of the layer resolution for that nozzle size, and I was very happy with how much print time I could cut out of these parts without seeing any reduction in quality. It was quickly evident that this printer was reliable and production worthy, so I moved it into one of my enclosures and I set up a time-lapse camera for a few more prints. You'll also notice that I switched over to a flex plate. We'll talk a little bit more about that later, but the main purpose of that was just so that I didn't have to wait for the glass bed to cool down before removing these parts. In a production environment, it's very important that things are moving as quickly as possible. These parts were printed in Filaments Depot Black HTPLA, and despite the time lapse with the printhead being parked on the side, I didn't see any sort of excessive stringing. And speaking of stringing, I decided to try some red PETG. Now, despite my level of experience with 3D printing, I will admit that sometimes I still struggle trying to dial in regular PETG. If you've never used it before, it can be a stringy, sticky nightmare where it just wants to stick to the nozzle and not the print bed. But in this particular case, with the X2, I had zero issues with it with a standard PETG profile. And so in the future, if I have to print with PETG, this will be my go-to printer. Now that we've become better acquainted with this printer, we can take a look at the pros and cons of this machine. So Artillery didn't revolutionize the 3D printing game with the Sidewinder X2, but it does have a feature list that stacks up really well against other printers in its price range. So for example, on the Artillery website, right now this thing's on sale for $349, and this is a very comparable machine feature-wise with the Ender 3 S1 Plus, and that's on sale on the Creality website right now for $429, and so this thing is significantly less expensive. Now the one thing the Creality printer does have that this doesn't is it comes with a flex plate, but the catch is that's a PC coated flex plate, not a PEI coated flex plate. And the problem with that is that the prints actually stick too well. You can actually damage the flex plate or even hurt yourself trying to get those prints off of those PC coated flex plates, and so you'll be replacing it with a PEI coated flex plate anyways. So there's really no difference between the two, and this one is much less expensive. And speaking of flex plates, you can get yourself a high quality double-sided PEI coated flex plate on my website embracemaking.com, and by purchasing from me, you're supporting my work. And these custom flex plates are made to the exact dimensions of any application, including the Sidewinder X2, which can be a little bit hard to find out there. Now, the one thing to watch out for on the Sidewinder X2 is that the glass build plate is bonded to the adjustment screws in the bottom. So when installing the flex plate, you wouldn't be removing the glass bed, you'd be applying the magnetic sheet right on top of the glass. And this has worked great for me on the X2 as well as the Genius Pro. I've done it to both of those machines. And the only thing that I found that I had to do was just increase my print bed temperatures by about 5 to 10 degrees. One other thing I like about this printer is the part cooling fan. It's slightly larger than what you'll find as standard equipment on other machines. And this means this printer does a very good job with bridging and just part cooling in general. And that makes a big difference with that Volcano nozzle because you're going to be printing very quickly and you're going to need good part cooling. Now, speaking of fans, the other thing I like is the fact that the hot end fan is controllable by the main board. And so what I mean by that is that when you first turn on the printer and the printer is cold, you'll notice that the hot end fan does not come on. This makes the printer very quiet. Also, when you finish a print and the hot end has sufficiently cooled down, the machine will actually turn that fan off. And that's different than what you'll find again on a lot of other brands of printers, including things like Creality. On those machines, I've noticed the hot end fan is just running constantly. And this seems like a small detail, but it does make a big difference because if you're the type of person like me who turns the printer on, runs a print, and may leave the house, or perhaps you go to work and you want to come home, that fan will be running for the rest of the day. And that's going to decrease the lifespan of those fans. On some of my other printers, I've had to replace the hot end fan multiple times, and it just becomes annoying. So I don't foresee that being a problem with this machine here. Also, one thing I really like is the AC heated bed. It reaches the target temperature very quickly, especially for a build plate of this size. And in a production environment, that just means a lot less wasted time waiting around for the bed to preheat. And another thing I like is the ribbon cable management. So on the Z-axis and X-axis, you got these nice ribbon cables. It cleans up the look of the printer. A lot of other brands still have cables flopping around everywhere, and that means those cables can get snagged on things and get damaged, whereas these things seem very reliable and very safe. And so up until this point, I've had a lot of good things to say about this printer, but this wouldn't be a fair and balanced review if I didn't have some critiques. And the first one is the screen. Now, it's the same screen that you'll find on the Artillery Genius Pro, which I had mentioned earlier, is essentially the same printer, just smaller. And there's nothing really wrong with it. It works fine, but to be honest, it is a tad underwhelming for a machine like this. I feel like the user interface could be improved, and this would purely be a firmware change. When looking at the icons, they feel a little bit playful, and I think they should change them to reflect the more serious name of the Sidewinder. I kind of want to feel like I'm operating some kind of fighter jet. Since we're on the topic of firmware, this is more of a critique about the brand than it is necessarily about this specific model of printer. But if you go to the Artillery website and you're looking for a firmware update for your machine, you'll find firmware on there, but it doesn't seem to have version numbers listed on the website, and it's very unclear what you're downloading and if it's actually an update for your machine. So I think they should get that a little bit better organized. And lastly, related to the firmware again, during my first few prints, I had a print where I ran out of filament and I got to test the filament change mid-print. So what happened was the filament runout detection sensor detects the absence of filament just fine, the printer starts the filament change procedure, and everything runs smoothly. I changed filament, I put the new stuff in, I pressed resume, but the extruder just sat there and skipped around hopelessly. And after a bit of research, what I found was that on the Artillery printers in the firmware, on a filament change during that advanced print pause phase, the printer changes back to absolute extrusion mode. And I'm a person that uses Prusa Slicer, which defaults to relative extrusion mode. And there are some advantages to using relative extrusion. You can Google that and find what they are. But the point is that I needed to change that in my slicer settings, and it just wasn't obvious to me from the beginning. And so if you're using Prusa Slicer like me, what you need to do is go into your slicer settings. So go into those printer settings and you want to change over to absolute extrusion. Then you want to go into the custom G-code section, go to the start G-code. You want to use M82 instead of M83. Finally, scroll down to the section before layer change, and you want to comment out G92E0. Now your filament change will run flawlessly mid-print. You're welcome. So that's it for this video. Overall, I would highly recommend the Sidewinder X2. It's earned its spot as one of my production machines, and I can't think of too many printers that offer this kind of value for that kind of money. And if you guys aren't looking for a printer this big, you can always consider the Genius Pro from Artillery. It's functionally the exact same printer, just in a smaller form factor, and you'll get it for even less money. So again, that's it. Thank you guys for watching. If you were looking to support my work, please visit my website, embracemaking.com. I would really appreciate that, and I hope to see you guys in another video. This is the Artillery Genius Pro, and in a previous video I took a look. That's not the Artillery Genius Pro. Sidewinder X2.